Water, often called the essence of life, is the most fundamental substance on Earth. Without it, life as we know it would not exist. The story of water on Earth begins billions of years ago, during the formation of the solar system. Scientists believe that water was delivered to Earth through a combination of processes, including the accretion of icy comets and asteroids during the planet's early formation. As these celestial bodies bombarded the young Earth, they brought with them vast amounts of water, which eventually accumulated on the planet's surface. Over time, Earth's water settled into oceans, rivers, lakes, and underground reservoirs, forming the hydrosphere that we recognize today. This early water provided the essential medium in which the first life forms began to emerge. Water's importance to life stems from its remarkable chemical and physical properties. Its molecular structure, consisting of two hydrogen atoms bonded to one oxygen atom, gives water its unique characteristics. Water is a polar molecule, meaning it has a positive charge on one side and a negative charge on the other. This polarity allows water to form hydrogen bonds with other water molecules, leading to high cohesion and surface tension. These properties are vital for processes like capillary action, which allows water to move through the tiny vessels of plants, bringing essential nutrients from the soil to the leaves. Another critical property of water is its ability to dissolve a wide variety of substances, earning it the title of the universal solvent. This characteristic enables water to carry nutrients, minerals, and gases essential for life, making it the medium for countless biochemical reactions within living organisms. Water's high specific heat capacity, its ability to absorb and retain heat, also plays a crucial role in regulating the temperature of the Earth's environment, ensuring a stable climate where life can thrive. Life depends on a series of complex chemical reactions that occur within cells, and water is the medium in which these reactions take place. In living organisms, water facilitates the transportation of molecules, the breakdown of nutrients, and the elimination of waste. Its solvent properties allow it to dissolve essential ions and molecules, making them available for cellular processes. For instance, in the process of photosynthesis, water molecules are split to provide the hydrogen needed to produce glucose, a primary energy source for plants and, by extension, all life forms that depend on plants for food. Similarly, in cellular respiration, water is a byproduct of the conversion of glucose and oxygen into energy, demonstrating its role in both the production and utilization of life-sustaining energy. Water covers approximately 71% of the Earth's surface, with the vast majority of it, about 97%, contained in the oceans. However, this salt water is not directly usable for drinking or irrigation. Only a small fraction of Earth's water, around 2.5%, is freshwater, and most of this is locked away in glaciers and ice caps. Less than 1% of the planet's water is accessible for human use, stored in rivers, lakes, and underground aquifers. The distribution of water is uneven across the globe, leading to diverse environments, from the lush rainforests of the Amazon to the arid deserts of the Sahara. This distribution shapes ecosystems and influences the development of human civilizations. Regions with abundant water sources tend to support rich biodiversity and dense human populations, while areas with limited water resources face challenges in sustaining life. Water is the foundational element that enables ecosystems to develop and thrive. In aquatic ecosystems, such as rivers, lakes, and oceans, water provides a habitat for a vast array of organisms, from microscopic plankton to the largest whales. These ecosystems are complex and interconnected, with water serving as the medium that supports life at every level of the food chain. Terrestrial ecosystems also depend on water, with rainfall and groundwater nourishing plants that form the base of the food web. The availability of water determines the types of vegetation that can grow in a region, which in turn influences the animals that inhabit those areas. For example, wetlands, which are areas where water saturates the soil, are among the most productive ecosystems on Earth, providing critical services such as water purification, flood control, and habitats for diverse species. Water's presence on Earth is not just a chemical accident, it is the cornerstone of life. From the origin of the first living cells to the development of complex ecosystems, water has been the essential ingredient that makes life possible. Its unique properties, its ability to dissolve substances, regulate temperature, and facilitate biochemical reactions, make it unlike any other substance on Earth. As we continue to explore the planet and beyond, water remains the key to understanding the potential for life, not only on our own world but on others as well. Water is the lifeblood that flows through every ecosystem on Earth, dictating the forms of life that can thrive in different environments. At the heart of Earth's ecosystems lies the water cycle, a continuous process that circulates water throughout the planet's atmosphere, surface, and underground. The water cycle begins with the sun's energy, which heats bodies of water, causing evaporation. Water vapor rises into the atmosphere, where it cools and condenses to form clouds. When these clouds become heavy with moisture, they release water back to the Earth as precipitation in the form of rain, snow, sleet, or hail. This precipitation is distributed across the planet, replenishing rivers, lakes, and groundwater. Some of it flows into oceans, while the rest is absorbed by the soil, taken up by plants, or stored in glaciers and ice caps. The water cycle is essential for maintaining the balance of ecosystems, as it regulates the availability of water in different regions and ensures that life-sustaining moisture reaches even the most remote corners of the Earth. Aquatic ecosystems, where water is the primary environment, are among the most diverse and productive on Earth. These ecosystems include oceans, rivers, lakes, wetlands, and estuaries, each with its unique characteristics and inhabitants. Oceans cover more than 70% of the Earth's surface and are home to a vast array of life forms, from microscopic plankton to the largest whales. The ocean's depth and vastness create a wide range of habitats, including coral reefs, deep sea trenches, and coastal zones. Coral reefs, often referred to as the rainforests of the sea, are particularly rich in biodiversity, supporting thousands of species of fish, invertebrates, and marine plants. These ecosystems are not only crucial for marine life but also for human economies, providing food, tourism opportunities, and coastal protection. Rivers and lakes are freshwater ecosystems that play a critical role in supporting both aquatic and terrestrial life. Rivers serve as arteries that transport water, nutrients, and sediments across vast distances, connecting different ecosystems. They provide habitats for fish, amphibians, and a wide variety of plant species, while also serving as water sources for humans, agriculture, and industry. Lakes, on the other hand, act as reservoirs of freshwater, supporting diverse communities of organisms and providing critical resources for surrounding wildlife and human populations. Wetlands are unique ecosystems where water saturates the soil for extended periods, creating a rich environment for plant and animal life. These areas are among the most productive ecosystems on Earth, supporting a wide range of species, including birds, fish, mammals, and amphibians. Wetlands act as natural filters, removing pollutants from water, and they play a crucial role in flood control by absorbing excess water during heavy rains. They also store carbon, helping to mitigate climate change by reducing greenhouse gas levels in the atmosphere. Estuaries, where freshwater from rivers meets the saltwater of the ocean, are another vital type of aquatic ecosystem. These transitional zones are characterized by high nutrient levels, which support a diverse range of species. Estuaries serve as nurseries for many marine species, providing safe habitats for young fish and invertebrates to grow before venturing into the open ocean. They also act as buffers, protecting coastal areas from storm surges and erosion. Water's availability, or lack thereof, shapes terrestrial ecosystems, influencing the types of plants and animals that can survive in a given area. The distribution of water on land creates a wide range of environments, from tropical rainforests to deserts, each with its unique characteristics and challenges. Rainforests are among the most water-rich ecosystems on the planet, receiving high levels of rainfall throughout the year. This abundance of water supports an incredible diversity of plant life, from towering trees to dense undergrowth, which in turn provides habitats for countless species of animals, insects, and microorganisms. The constant presence of water in rainforests drives high levels of primary productivity, meaning that these ecosystems can support large numbers of species and complex food webs. Rainforests also play a crucial role in regulating the global climate by absorbing carbon dioxide and releasing oxygen through photosynthesis. Grasslands, which receive moderate levels of rainfall, are dominated by grasses rather than trees. These ecosystems are found on every continent except Antarctica and are home to a variety of herbivores, such as bison, antelope, and zebras, as well as predators like lions and wolves. Grasslands are shaped by the availability of water, with more water supporting taller grasses and less water resulting in shorter, drought-resistant plants. These ecosystems are also vital for agriculture, providing fertile soil for crops and grazing land for livestock. Deserts are defined by their lack of water, receiving less than 25 centimeters, 10 inches of rainfall per year. Despite these harsh conditions, deserts are home to a surprising variety of life, including cacti, shrubs, reptiles, and mammals that have adapted to survive with minimal water. Desert plants have evolved to conserve water through features like thick, waxy leaves and deep root systems, while desert animals are often nocturnal, avoiding the heat of the day. The scarcity of water in deserts limits primary productivity, resulting in simpler food webs and lower biodiversity compared to water-rich ecosystems. Forests in temperate regions, where water is moderately available, are characterized by a mix of deciduous and coniferous trees. These ecosystems experience distinct seasons, with varying levels of precipitation throughout the year. Forests support a wide range of species, from large mammals like bears and deer to birds, insects, and fungi. Water availability in these ecosystems influences the growth and health of trees, which in turn affects the entire ecosystem, including the soil, understory plants, and animal populations. Watersheds, also known as drainage basins, are land areas where all the water that falls as precipitation flows into a common outlet, such as a river, lake, or ocean. Watersheds are vital for collecting, storing, and distributing water across different ecosystems, acting as natural networks that connect various habitats. Each watershed is unique, with its topography, climate, and vegetation influencing the flow of water. In mountainous regions, watersheds often contain fast-flowing rivers and streams that carve through valleys, creating diverse habitats for plants and animals. In flatter areas, watersheds may consist of slower-moving rivers, wetlands, and floodplains, which provide critical services such as water filtration and flood control. Watersheds are essential for maintaining the health of ecosystems, as they regulate the flow of water and nutrients, support biodiversity, and provide habitats for countless species. They also play a crucial role in human life, supplying drinking water, supporting agriculture, and serving as sites for recreation and tourism. However, watersheds are vulnerable to pollution, deforestation, and other human activities that can disrupt their natural functions and threaten the ecosystems they support. Water is the driving force behind the formation and sustenance of ecosystems, influencing the distribution of life on Earth and the diversity of species within each habitat. From the vast oceans to the smallest streams, water creates the conditions necessary for life to flourish, shaping the landscapes and environments we see today. Understanding water's role in ecosystems is essential for protecting these natural systems and ensuring that they continue to provide the resources and services that all life depends on. Water is not only essential for life but also plays a critical role in regulating Earth's climate. The presence and movement of water in its various forms, liquid, vapor, and ice, create a dynamic system that influences weather patterns, stabilizes temperatures, and drives the global climate system. The water cycle, the continuous movement of water through the Earth's atmosphere, surface, and underground, is a fundamental driver of weather patterns. As water evaporates from oceans, lakes, and rivers, it rises into the atmosphere as water vapor. This vapor forms clouds, which are transported by winds across the globe. When conditions are right, the vapor condenses into droplets or ice crystals, eventually falling back to the Earth as precipitation. This process is central to the distribution of weather patterns. For instance, the amount of water vapor in the atmosphere can determine whether a region experiences drought or abundant rainfall. The movement of moist air masses can lead to the development of weather systems such as hurricanes, monsoons, and thunderstorms. In coastal regions, the interaction between land and sea influences the development of sea breezes, which can moderate temperatures and bring moisture to the land. The water cycle thus connects different parts of the Earth, creating a global climate system where weather patterns in one region can influence conditions elsewhere. Water has a high specific heat capacity, meaning it can absorb and store large amounts of heat without experiencing significant changes in temperature. This property makes water a key stabilizer of the Earth's climate. The oceans, which cover more than 70% of the Earth's surface, act as vast heat reservoirs, absorbing solar energy during the day and releasing it slowly over time. This process helps to moderate temperature fluctuations between day and night, as well as between seasons. In coastal areas, the proximity to large bodies of water leads to milder climates with less extreme temperature variations. During the summer, the ocean absorbs heat, preventing coastal regions from becoming excessively hot. In winter, the ocean releases stored heat, keeping coastal areas warmer than inland regions. This temperature moderation by the oceans creates favorable conditions for diverse ecosystems and human populations. The heat capacity of water also plays a crucial role in regulating global temperatures through ocean currents. These currents, driven by the wind, the rotation of the Earth, and differences in water density, transport warm water from the equator to the poles and cold water from the poles to the equator. This redistribution of heat helps to maintain a relatively stable global climate and prevents the extremes of temperature that would otherwise occur. Ice and snow, which are frozen forms of water, have a significant impact on the Earth's climate due to their high albedo, or reflectivity. Ice and snow reflect a large portion of incoming solar radiation back into space, helping to keep the planet cool. This effect is most pronounced in the polar regions, where vast ice sheets and glaciers cover the land and sea. The polar regions act as Earth's refrigerators, playing a critical role in maintaining the planet's energy balance. The cooling effect of ice and snow influences global weather patterns by helping to drive the circulation of air and ocean currents. For example, the difference in temperature between the warm equator and the cold poles drives the movement of air masses, leading to the formation of jet streams and other atmospheric circulation patterns. However, the warming climate poses a significant threat to this balance. As global temperatures rise, ice and snow are melting at unprecedented rates. This not only contributes to rising sea levels but also reduces the Earth's albedo, allowing more solar radiation to be absorbed by the planet's surface. This creates a feedback loop, where the loss of ice leads to further warming, which in turn accelerates ice melt. This feedback loop has the potential to disrupt global climate patterns, leading to more extreme weather events and long-term changes in the climate. Water vapor is the most abundant greenhouse gas in the Earth's atmosphere, and it plays a crucial role in regulating the planet's temperature. Greenhouse gases, including water vapor, carbon dioxide, and methane, trap heat in the atmosphere, preventing it from escaping into space. This natural greenhouse effect is essential for maintaining temperatures that support life on Earth. Water vapor amplifies the greenhouse effect through a process known as positive feedback. As the Earth's surface warms, more water evaporates, increasing the concentration of water vapor in the atmosphere. Since water vapor itself is a greenhouse gas, this leads to further warming, which in turn causes more evaporation. This feedback loop helps to stabilize the Earth's climate over time, but it also means that any initial warming from other sources, such as increased carbon dioxide, can be magnified by the presence of water vapor. The role of water vapor in the greenhouse effect underscores the interconnectedness of the Earth's climate system. Changes in one part of the system can have cascading effects, influencing weather patterns, global temperatures, and the distribution of ecosystems. Understanding these interactions is key to predicting and mitigating the impacts of climate change. Climate change is profoundly affecting the water cycle, with far-reaching consequences for the Earth's climate and ecosystems. Rising global temperatures are increasing the rate of evaporation, leading to changes in precipitation patterns. Some regions are experiencing more intense and frequent storms, while others are facing prolonged droughts. These shifts are disrupting the balance of water availability, affecting agriculture, water supplies, and the health of ecosystems. In polar regions, the melting of glaciers and ice sheets is contributing to rising sea levels, threatening coastal communities and ecosystems. The loss of ice also reduces the Earth's albedo, further accelerating global warming. In addition, the warming of oceans is affecting marine life, altering the distribution of species and the productivity of fisheries. Coral reefs, which are highly sensitive to temperature changes, are experiencing widespread bleaching and die-offs, with serious implications for the biodiversity they support. The disruption of the water cycle is also increasing the frequency and severity of extreme weather events, such as hurricanes, floods, and heat waves. These events not only cause significant damage to human infrastructure and livelihoods but also have lasting impacts on ecosystems, leading to habitat loss, changes in species distributions, and declines in biodiversity. Water is a central player in the Earth's climate system, regulating temperatures, driving weather patterns, and maintaining the delicate balance that supports life. Through its various forms, liquid, vapor, and ice, water influences nearly every aspect of the global climate, from the distribution of ecosystems to the frequency of extreme weather events. As climate change intensifies, the role of water in moderating the Earth's climate is becoming more critical and more vulnerable. Understanding the complex interactions between water and the climate is essential for addressing the challenges posed by a changing world. Protecting and managing water resources, preserving ice and snow in polar regions, and reducing greenhouse gas emissions are all vital steps in safeguarding the Earth's climate for future generations. Water has been integral to the development and sustainability of human civilizations. From ancient societies to modern cities, access to clean and reliable water sources has shaped human history, culture, and progress. Water has always been a critical factor in the establishment and growth of human societies. Early civilizations often flourished around major water sources, such as rivers, lakes, and coastlines, which provided essential resources for survival and development. Ancient Mesopotamia, considered one of the cradles of civilization, arose between the Tigris and Euphrates rivers. The fertile land provided by these rivers enabled the growth of agriculture, which supported large populations and the development of complex societies. Irrigation systems were developed to control and distribute water for farming, leading to the growth of cities and the rise of early empires. Ancient Egypt similarly depended on the Nile River, which was central to its agricultural productivity. The annual flooding of the Nile deposited nutrient-rich silt on the fields, allowing Egyptians to grow abundant crops. This predictable water supply supported the development of a sophisticated society with advances in writing, engineering, and architecture. In ancient India, the Indus River Valley civilization thrived due to its access to the Indus River and its tributaries. The civilization developed advanced urban planning and water management systems, including sophisticated drainage and bathing facilities, that are evident in archaeological remains. Ancient China benefited from the Yellow River and Yangtze River, which were crucial for agriculture and transportation. The development of irrigation systems and flood control measures helped sustain large populations and foster technological and cultural advancements. As human societies evolved, so did their use of water. The development of agriculture was a turning point in human history, and water played a central role in this transformation. Agricultural irrigation has been essential for growing crops in regions with variable rainfall. Early innovations in irrigation techniques, such as canals, aqueducts, and wells, allowed societies to expand their agricultural activities and support larger populations. Today, modern irrigation systems, including drip and sprinkler systems, continue to enhance agricultural productivity and manage water resources more efficiently. Industrialization brought new demands for water. The growth of industries such as textiles, metallurgy, and energy production required significant quantities of water for processes like cooling, cleaning, and transportation. Water-powered machinery, such as water wheels and mills, played a crucial role in the early stages of industrialization. In the 21st century, the water needs of industries have evolved, with a focus on sustainability and reducing water consumption. Innovations in water recycling, treatment technologies, and efficient industrial practices are helping to minimize the environmental impact of industrial water use. Despite its importance, managing water resources presents significant challenges. Rapid urbanization, population growth, and climate change are putting increasing pressure on water supplies. Urbanization has led to the expansion of cities and the conversion of natural landscapes into built environments. This has increased the demand for water and put strain on existing water infrastructure. Urban areas also face issues related to water pollution, as runoff from roads, industrial sites, and sewage systems can contaminate water sources. Climate change is altering precipitation patterns, leading to more frequent and severe droughts and floods. Changes in temperature and weather patterns affect the availability of water in different regions, impacting agriculture, water supply, and ecosystems. Water scarcity is a growing concern, with many regions facing shortages due to over-extraction, pollution, and uneven distribution. Ensuring access to clean and safe water for all communities is a critical challenge that requires effective management, conservation, and investment in water infrastructure. Addressing these challenges involves a multifaceted approach that includes improving water conservation, investing in infrastructure, and promoting sustainable practices. Innovations in water technology, such as desalination, wastewater recycling, and smart water management systems, offer promising solutions for meeting future water needs. Public awareness and education are also crucial for fostering a culture of water stewardship. Educating individuals and communities about the importance of water conservation and responsible use can drive positive changes in behavior and policy. As we move into the future, the challenges facing water resources are becoming more complex and urgent. Addressing these challenges requires innovative solutions, collaborative efforts, and a commitment to sustainable practices. Climate change is one of the most pressing challenges affecting water resources. Rising temperatures are leading to more frequent and severe weather events, including droughts, floods, and storms. These changes affect the availability and quality of water, as well as the functioning of ecosystems. Melting glaciers and ice caps contribute to rising sea levels, which can lead to the contamination of freshwater sources with saltwater and increase the risk of flooding in coastal areas. The global population is expected to reach nearly 10 billion by 2050, putting increased pressure on water resources. Urbanization and industrialization further exacerbate the demand for water, leading to competition for limited supplies. Rapid population growth and the expansion of cities can strain existing water infrastructure, leading to issues such as inadequate access to clean water, increased pollution, and water scarcity. Water pollution remains a significant challenge, with contaminants from agricultural runoff, industrial discharges, and untreated sewage affecting water quality. Pollutants such as pesticides, heavy metals, and pharmaceuticals can harm aquatic life, disrupt ecosystems, and pose risks to human health. Addressing water pollution requires improved waste management practices, stricter regulations, and the development of advanced water treatment technologies. Water scarcity affects many regions around the world, with billions of people lacking access to reliable and safe water sources. Scarcity can result from natural factors, such as arid climates, or from human activities, such as over-extraction and pollution. Managing water scarcity involves balancing competing demands, improving water efficiency, and investing in infrastructure to ensure equitable access to water. Innovations in water treatment are helping to address issues of pollution and scarcity. Advanced treatment technologies, such as membrane filtration, reverse osmosis, and UV disinfection, offer effective solutions for purifying water and removing contaminants. Desalination technologies are also being developed to provide fresh water from seawater, offering a potential solution for regions with limited freshwater resources. Water recycling and reuse are becoming increasingly important in managing water resources. Technologies for treating and recycling wastewater allow for the recovery of water for non-potable uses, such as irrigation, industrial processes, and toilet flushing. Implementing water recycling systems can reduce the demand for fresh water and minimize the environmental impact of wastewater. Smart water management technologies use data and automation to optimize the use of water resources. Sensor networks, data analytics, and remote monitoring systems provide real-time information on water usage, quality, and infrastructure conditions. These technologies enable more efficient management of water supplies, early detection of leaks, and improved response to water-related issues. Promoting sustainable water practices is essential for addressing future challenges. This includes implementing water-efficient technologies, adopting conservation practices, and encouraging responsible water use. Sustainable practices also involve protecting and restoring natural water systems, such as wetlands and watersheds, to maintain their ecological functions and support biodiversity. Effective water management requires collaboration between governments, businesses, and communities. Collaborative governance approaches involve stakeholders in decision-making processes, ensuring that diverse perspectives are considered and that water resources are managed equitably. Partnerships between public and private sectors can drive innovation, investment, and effective solutions for water management. Education and advocacy play a crucial role in addressing water challenges. Raising awareness about the importance of water conservation, promoting sustainable practices, and advocating for policy changes can drive positive change. Engaging individuals, communities, and organizations in water stewardship efforts helps to build a culture of responsibility and ensure the long-term sustainability of water resources. The future of water management presents both challenges and opportunities.